Let us now discuss the primary and secondary focus of a thin lens. About a thin lens we already studied, and we can also write that every thin lens has two focal points on opposite sides of the lens. These are called primary and secondary focal points. Let's discuss about the two focal points in detail. About primary focus of a lens or primary focal point of a lens, we can say if a point object is located at the primary focus of a thin lens, its image will be produced at infinity. Here you can see a realistic situation that if there's a convex lens and on the left side of the lens a real object is placed at its focus, then we can see all those light rays which are incident on the convex lens will become parallel after refraction from the two surfaces of lens, and parallel refracted rays will produce image at infinity. So this focal point will be termed as f1 or the primary focus of this convex lens. Similarly, for a concave lens, here we can see if a converging beam of light is allowed to incident on the lens such that it is intersecting at a point on the other side of lens, then after refraction from the two surfaces of the lens, these light rays will become parallel to the principal axis and produce an image to infinity. So here if there is a virtual object located at a point which is producing an image to infinity, this point will be termed as f1 or the primary focus of the concave lens. This is the way how a primary focus of a convex and a concave lens is defined. So this is the way how primary focus is defined. Primary focus is defined for convex and concave lens. Once again I repeat, you must keep in mind this is the point where in case of convex lens a real object should be placed to produce its image at infinity, and in case of a concave lens a virtual object should be located by incidence of a converging beam so that its image will be produced at infinity. These points we term as a primary focus of the lens. Let's continue for the secondary focus on the next sheet. Let's continue our discussion with the secondary focus of a thin lens. Then here secondary focus can be defined as if an object is at infinity, then after refraction through a thin lens, its image is produced at a point termed as secondary focus of the lens. Here in this realistic situation we can see if there is a convex lens, then from an object placed at infinity, parallel incident rays will incident on the lens, and after refraction all these light rays will converge at a point on principal axis, and this point we term as f2 or the secondary focus of the lens. Similarly, for a concave lens, here you can see if an object is placed at infinity, parallel rays will incident onto it, and after refraction the rays will diverge and appear to originate from a point which is f2 or secondary focus of this concave lens. So for the convex lens, here we can see a real image is produced at secondary focus, and in case of a concave lens, a virtual image is produced at secondary focus. So this is the way how secondary focus is defined for convex and concave lenses. This is the way how we define. In convex lenses, on secondary focus, a real image is produced when parallel rays will incident onto it, and in case of concave lenses, virtual image is produced on secondary focus when parallel rays are allowed to incident onto it.